Hello and welcome to this Science Vision video. Now in this video we're looking at chemical symbols and simple chemical equations. Let's start first of all at looking at chemical symbols themselves. Now you may know, I hope you do by now, that every element is represented by a different symbol. For example, we've got Fe for iron, Na for sodium and O for oxygen. Now some of these are pretty straightforward. O, oxygen, yep, no problem there whatsoever. Fe for iron, that one's a bit more difficult. This comes to the word ferrous. So ferrous is the word for iron, Latin word for iron. So take the first two letters there, Fe. Notice it's a capital followed by a small e. Okay, iron. Na for sodium. I haven't got a clue what Na, where it comes from. Perhaps you can find out. But again, it's capital followed by lowercase for sodium. Okay. Now all these symbols are in, as you now know, the periodic table. We can use symbols to show molecules of compounds, and they can also show us a ratio of different elements which combine to make up compounds. Confused? Examples. So here's an example here. H2O. You may be familiar with this. This is water. The 2 there tells us there's 2 hydrogens and there's 1 oxygen. We don't put the 1 there, but you can imagine it there. So 2 hydrogens and oxygen. This is carbon dioxide. Carbon, there's 1. Di means 2, so dioxide, 2 oxygens there. And over here we've got something called ammonia. Ammonia is NH3. You've got 3 hydrogens and 1 nitrogen. Okay, so that's a simple introduction there to chemical symbols. Let's just recap on what we've looked at earlier in terms of chemical symbols. Very simple one, sodium hydroxide. Here's a formula, NaOH, tells us we've got 1 sodium, 1 oxygen, 1 hydrogen. Right, let's increase the complexity. Here's calcium carbonate, 1 calcium, 1 carbon, 3 oxygens. I hope you can see where they're coming from. Okay, a bit more complex still. Magnesium nitrate. Now magnesium's got 1 magnesium. Now notice there's a 2 here outside these brackets. Now the 2 multiplies, doesn't add, it multiplies everything inside. So 2 times 3 is 6 oxygens. 2 times 1 is 2 nitrogens. So magnesium nitrate, we've got 1 magnesium, 2 nitrogens, 6 oxygens. And last example, this is as complex as it's going to get. The 3 multiplies everything behind. Okay, so be really careful doing this. Start first of all by looking here. We've got 3 times 4 is 12. Okay, times 3 is 36. So it's 36 atoms of oxygen. 3 times 1 is 3, times 3 is 9 atoms of sulfur. We've got 2 aluminiums, times 3 is 6. So here we've got 6 atoms of aluminium, 9 atoms of sulfur, and 36 atoms of oxygen. Now that's as complex as you're likely to get. So if you can crack that one, you've done really well. Let's move on. Equations. Now, as in Marmite, you either love equations or you absolutely hate them. Well, I hope you're going to love them. An equation basically is a shorthand way of saying what's happening in a reaction. In a reaction, you've got reactants, the things that are reacting together on the left hand side of the equation. The products, the things that are being formed on the right. Example, you add sodium to water, you get quite a violent reaction. You get sodium hydroxide formed and hydrogen gas. So the reactants are sodium and water, products, sodium hydroxide and hydrogen. Put in the symbols, Na plus H2O is NaOH plus H2. Now here we come to the bit people hate, the balancing bit. Everything's got a balance on both sides of the equation. Just check. We've got 1 sodium there, 1 there. That balances. 2 hydrogens there, but look, we've got 1 and 2 makes 3. You've got 3 this side, 2 that side. That's not balanced, is it? 1 oxygen, 1 oxygen. Right. Now, when you're balancing equations, you cannot split the formula. You can't put a number in there, for example. You've got to put a number in front. The only way to balance equations is putting numbers in front. So we know that we've got too many hydrogens here. So what we can do, we've got to put 2 there, for example. That makes it 4. We've got 3 there. So what can we do? Put a 2 there. So 2, that makes 4. So that means now that the hydrogens are balanced. We've got a 2 there, 2 oxygens, 2 there, 2 oxygens, 2 sodiums. Let's check, shall we? There we go. Look, 2 sodiums, 2 sodiums, 4 hydrogens, 4 hydrogens, 2 oxygens, 2 oxygens. So we're now balanced. Last stage is always put in the state symbol. Sodium's a solid, water is only liquid, So my hydroxide is an aqueous solution, it's dissolved in water, it's just an aqueous solution, and hydrogen is a gas. Let's just check on those state symbols. S is a solid, L is a liquid, AQ is when something's dissolved in water, and G is a gas. Now when writing equations you need to be able to, first of all, simplest, write word equations when required. Secondly, recall the formula of simple covalent compounds, and I'll give you some of these in a moment. Secondly, write down formula for simple ionic compounds, and again I'll give you some of these. Interpret chemical formulae of molecules, you've just done this, we're looking at NaOH and saying what's what. Interpret symbol equations including state symbols, again you've just done this. Let's look now at some simple covalent formulae. Now there's no way around this, you've got to basically learn some of these. So water you should know H2O, carbon dioxide CO2, ammonia NH3, hydrogen H2, oxygen O2. These are what are called diatomic gases. These gases go around in pairs. So hydrogen H2, O2, N2. Diatomic means two atoms, so 2, 2, 2. Sulfur dioxide SO2 and methane CH4. So those are covalent formulae. Ionic formulae, in all these you've got a metal and a non-metal. So sodium chloride NaCl, calcium chloride CaCl2, magnesium oxide MgO, hydrochloric acid H. Now hydrogen can sometimes have metallic state, so H there is as though it's acting as a metal. So it's H plus is the ion there. HCl, H2SO4 for sulfuric acid, HNO3 for nitric acid, sodium hydroxide NaOH, potassium hydroxide KOH, calcium hydroxide Ca in brackets OH twice, calcium carbonate CaCO3, aluminium oxide Al2O3, iron oxide Fe2O3. So it's well worth learning these. Not to say all of these, but a good number to recall later on writing equations. Okay, well that's it for this video. Hope you've enjoyed it, and don't forget you can find more of my videos at www.sciencerevisionvideo.com, and I'll be back again very soon. Bye for now.